So next part is we will try to model a case study in the CCaLC tool so that we can now explore this function and use functions and features by using them. So let me open what is this case study about first, just to briefly talk about the case study. So we are taking this as an example of to assess the carbon footprint for biogas to produce electricity. So the goal and the scope, again, as we will follow the steps as we were defining in LCA, goal and scope, system boundary, functional unit, etc. So our goal is here, like in a simple term, assess the carbon footprint of electricity from biogas. Unit of functional unit is 1 megawatt hour of electricity. System boundary is created to gray, so we would include every option. So in terms of this is more diagram of system boundary. So it relies on the various agriculture waste and residues, which are then transported, collected and transported to AD plant, where it will go through screening to remove any unwanted substances. Then it shredded or mixed and fed into the digester. So during digester operation, there will be some emissions which will take into account, but as an output, the digester main output is biogas, which goes to combined heat power plant, and then electricity, some of electricity and heat is used within the system, but others remaining will be exported. The digestate would require some sort of post-treatment before sending to apply in a farm. And since this digestate have some fertilizer value and it is becomes a byproduct, we may have to allocate the impacts as well accordingly. Generally, we would also, in the system, we would also include the construction of the plant, etc., and also any emissions occurring during each stages. For this case study, at the moment, I'm not going through the construction part, but we'll focus on the operational and feedstock part. So then we collect the inventory data for the plant. So as we're saying, there are 3 stages: distinct AD plant, combined heat and power generation, and then the digestate application and treatment. So AD plant data. So here we have assumed some feedstocks, say cattle slurry, maize silage. It's a combined, so different feedstock, mixed wheat and food waste. So these are some quantity which we estimated will be required to generate 1 megawatt hour as a functional unit of electricity. And this AD plant itself would generate 600 kilogram, or in terms of meter cube, 500 meter cube, 50 meter cube of a biogas, which goes to the CHP plant. And then there is a digestate for land farming. And the emissions during the AD plant are also listed here: ammonia, air emissions, all as air emission, ammonia, hydrogen sulfide, methane, and nitrous oxide. And then I'll show the inventory for the CHP plant. So CHP plant requires biogas as a feed, and then only here as input we are showing as a lubricant oil is used, which may require for any mechanical parts. Output here is our 1 megawatt as a net electricity. So after all in use, subtracting all inside your parasitic usage. There is some heat generation because it's a combined heat power plant. Part of the heat will be used within the, to meet the requirement for either drying of digestate or the heat of the AD plant. But then if there is additional heat, because here we assume that it is being not used or wasted. And any combustion related emissions we will have just main emissions related to have counted here, but we can add if we have further data for other emissions. So it's carbon monoxide, sulfur oxide, methane, nitrogen. This carbon dioxide, this is biogenic because there is a difference between fossil and biogenic carbon dioxide. So biogenic carbon dioxide is carbon dioxide which is produced from biomass, and generally in carbon footprint this is not taken into account. It's assumed as a zero carbon footprint. The reason is that because it has been recently taken from the atmosphere while the growth of biomass happened, through photosynthesis process, hence it is it's being released into the environment. It is different in case of fossil fuel because that has taken several thousand of years to sequester from atmosphere, and once we release it, we can't be again sequestrated so quickly. So that's why we would have to specify whether it is biogenic or not. Waste, this is again lubricant oil. Once it will be wasted, we are assuming that it will be incinerated. In terms of then digested, we are also including that, okay, digested will be dried and applied in a field. And so for application, it will require, say, diesel. We are assuming that for used in that machine or a spreader. And during application, it will also release some emission of like ammonia, methane, etc., and leach it to water. And this water total has, we estimated that these digested has so much N equivalent in terms of N fertilizer, P fertilizer, and K fertilizer. So if we apply, we would not need this as mineral fertilizers, which we can either subtract impacts or allocate. Again, the feedstock would require transport, so we are here making some assumption regarding transport. So cattle celery, we are saying, okay, it will require 5 kilometer transport, and it will be transported this through 7.5 ton truck. Maize, and each has different transport mode and distances, and that we will enter into the system. So these are the inventory part, which we, as I said, this is the most time consuming part to collect all data. And once we have all the data, now we can go to the tool and start modeling. So I will start with the first stage and then next stage, etc. within the tool. So let me open a tool, and I'm starting a new case study. So again, if I'm starting a new case study, I will start with the entering system details. So here, if I click, I'll say, so name of the study, we can say, is it biogas? You can say electricity from biogas. And functional unit, we can define here 1 megawatt hour as, etc. And if we want to change, we can change the all mass or those units, but if you're not, we just keep it. Let me change the, say, currency unit to pound instead of pound here, and then we can add any data, etc., column or time, etc. So data collected, we can say, okay, 2018, and any comment if I want to add here, can add here. And once I click OK, then it will update the system. So it will again often prompt with this question, and once we click yes, it will show us that we have now some basic features we have added for this case study. And then the next stage is, since we know we are three distinct stages, so before defining any materials, I would first define the production stages, because to name them. So here, for example, stage 1, instead of stage 1, I want to call it AD plant, so that we know if we are sending any material, which stage we are talking about. So if I update, it will show. And then similarly, I'll do for second stage, which we say, okay, CHP plant. And then sorry, if I go back to production, and if I click here, define stage, and the third is, okay, digested application. Update. And then we have just named them as a basic event to start with. Under each stage, so we can further define whatever the emission, etc. later. First, as we knew, we have for AD plant, we need to define the feedstock, which we call it here as a raw materials. So just to remind, the raw material, we have four options: cattle slurry, maize silage, straw, food waste. And here, if we click on define material, and then we can either look into to find that material from the database, or we can easily click under the search. So for example, I want to look at the slurry. So I click slurry, type slurry and search, and then it gives me a couple of options. I think this one is more relevant, farmyard slurry. So I just select and I'll see it shows what this about a little bit. So, okay, I select this as a slurry and it goes to our AD plant, and the quantity which we had 6,000 kilogram. And let's say I just select low quality because I'm not 100% sure about this quality. I just put as low. In terms of cost, okay, let's assume this is a freely available. User doesn't not have to pay, so we just put a 0 value. And if we update it, then it will show the carbon footprint. And similarly, I can define other materials which are our feedstocks. So the second I define maize silage. And again, when I search, there are for silage we have various options. So under maize silage, we can have this is conventional German, UK, or we can have this is a more European database silage manure maize at farm. So we can select, and also again here look at this is okay. This is for Switzerland database, and based on those options, we can select one of them and then select again. It goes to AD plant and quantity which was around 250 kilogram. Let's say data quality here is medium, and select maybe user may have to pay for this. So let's assume it as a point. I'm just making a number 0.01 per kilogram, so 10 euro maybe per ton, etc. So I'm just up for the sake of example, I'm just adding this number for the cost, and if I update it, then it's added. And similarly, then we add another material which was straw, and I can again search it. So again, straw, we have a barley straw, but we are looking for say wheat straw, and so there are wheat straw as well here. So let me select this one, and this goes to again same stage, and the quantity we enter was 350. Say medium, okay. And cost again, say user has to pay, and it's a 20 euro per ton. So we had that. So update it, and then it will add. So next was the food waste. Again, if we click food waste search, we may not find any data here as a data because this is a waste, it may not be available. So if I search, there is empty. So in that case, we have an option of creating our own substance. So we can say modify substance, create new item, and our item is food waste. And since it's a waste, we can assume that it has no burdens or impact associated before it. It is before the production. So all previous stages of production are associated with the product. So we give a value of 0, 0 for those, etc. We don't need to define other impact if we are not assessing, but we can just add only carbon footprint. And while we create our new item, we can add any other related data. So when this means year, location, these are not mandatory, but it's good to add all those data. What is the source of this data, and the quality, this is mandatory, we need to add, and we say hi, for example. And any comments about this data we can add here. And then we update, then this item has been added. Now if I go back to user database, I can find this food waste here, and again send it to, and we are assuming that this, and quality is okay, and then cost we are assuming again 0, for example. Update. So now we have entered under all those materials which will be going to the AD plant. In addition, we will be sending what we said lubricant oil, which is used in the CHP plant. So which we can add here. If I search lube oil, so there's a lubricant oil. There are 2 data, so we can look into detail which one is more appropriate and select accordingly. And so this is lubricant oil data from EcoInvent database, and so probably this is more suitable. I'm just selecting, and this goes to CHP plant. I select from here and add the quantity was 0.5 kilogram per functional unit, and quality is medium. And the cost we paid for this 0.5 kilogram, say €1 for example. And if we add it, so we have so now we have defined all the materials required in there. So next stage will be defining their transport. So we click on the transport icon here, which is here, and then we select define here. Then it will show us which material we want to define. So we can start from the first. For example, we had this slurry, which we say, okay, this is now 7.5 ton truck. We have again a couple of options. We can look in the database. There is this option here, or under EcoInvent database, we can look under further details. So again, it's not exactly 7.5, but there are options between 3.5 to 7 truck, or 7.5 to this. And also it gives you a little bit more detail, whether it's a Euro 3, 4, 5, etc. So we can select which one is more appropriate. So let me select one of them. They say Euro 5, and it's between 3.5 and to 7.5. And then the distance, which was, I think we had given it for, let's assume it's only 5 kilometers transported. And the high update, and so on. So, and then we go to next, which was our silage, which we can also, if we know if the all of the remaining, for example, are transported with the same type of truck and same distance, we can select all together, which will make easier, for example. So if, for example, if I'm selecting these remaining 5 all together, I can select define, and I select the same truck. For example, it was 22 ton truck, if I want to select, and if I say the distance was 15 kilometers for all of them, I can do that. And medium, and if I update it, then it will show all of them. Again, so once means this is a relatively quicker way to enter data rather than clicking each. And now if I want to modify, for example, I say realize no, food waste mine is not transported for 15 kilometers, it requires 100 kilometers. I just click it and say 100 kilometers. Or if I want to change the type of truck, we can change the truck or carrier as well. So I just change the distance here, and so now it's 100 kilometers. It has been calculated accordingly. And so once we have defined the transport of materials, next we can go to the each production stage and define the emissions occurring within the stage. So in AD plant, as if you recall, there were emissions of ammonia, hydrogen sulfide, methane, etc. So we click here, AD plant, and click on the define stage. So there are these 3 options we have to define. One is output. So output of AD plant, as we are saying, is a biogas. So we just type it here, biogas, and it goes next to CHP plant, and the quantity, it was 600 kilograms. So I add 600 kilograms, and if I update, so that will add. In addition, the second output was digestate. So I add digestate, and this goes to digestate application, and the value was 3,300. So I add an update. So these outputs are shown here as being coming from this plant. And then the emissions, so we have this all emissions we could add. So emissions to, for example, air, and then the substance was, one was ammonia. So we look at the ammonia emissions here, and then add the ammonia emission, which was 0.9 kilogram. And again, it will ask for the quality. If we know this data is good quality, we can say medium or high. If it is low quality, then we select a quality. I'm just making it as a medium quality, okay? And update. And so same way we would add the other emission. So the next was hydrogen sulfide. So from substance we will select hydrogen sulfide, which is under here. If I can find it. So yeah, hydrogen sulfide here. And then the quantity was only 0.03, and we say okay, so it's measured, so quantity is high. Okay, accordingly give it. And the emission was methane. So select methane. Methane emissions. Again here, methane emissions, and we can add methane to here, and the quantity was 6.5 kilogram. So I'll just keep adding that and say medium update. And the other emission was nitrous oxide. Nitrous oxide here, and the quantity was 0.06 kilogram. And when we select those emissions, it will also show us impact of each, whether in terms of carbon footprint or acidification or eutrophication here. And select update, and then so we have defined the all emissions and everything from this state. This though uses all heat or energy is being currently used in this case study. We are assuming that it's used from its own internal energy, so that's why we don't need to define. But if a particular process requires any energy, we can also say, for example, if we require say electricity to run its motors, or it requires initial, for operation for heating diesel or heat from natural gas, we can select and add accordingly. Okay. If there is any other waste, which we can add as well, but there was no, so we are just leaving it as it is. And then we go to the next stage, which was in that case is the combined heat power plant. But also the other thing was there are two outputs from here. One is biogas, which directly goes to the plant, and the other is the digestate, which will require some transport to go to the digestate application or to the farm. So here we can add that transport as well. So here it gives the option, because biogas does not require transport. We will add transport, and let's assume a truck from here. I'm just assuming particular truck, and then we can add distance of say, let's say 15 kilometers and low. So that transport has been defined. And also for transport, actually, we could also have if we know the cost of transport, we can add as well. So I just click on this. And so if we want to modify, if we have by mistake entered the incorrect truck or distance, we can also always click on this and then modify it will show. So for example, I missed to add the cost of the transport. So here I can say, okay, this transport of per kilometer requires some, cost. No, it's all total cost of this digested transport will require say 10 euros. I'll just add it. Okay. And then it will be shown. And in CHP plant, again, we have some combustion related emissions which we can enter. So the emissions were, so let me define first stage. So CHP output of stage was electricity. So we write it here. And it is an energy unit, we can write, and then it goes to directly to use, and value is, because it's a 1 megawatt hour, and here since we have said megajoule, so it will be 3600 megajoules. Update. And then there are emissions which we can define here. So emissions to air, for example, was mainly carbon monoxide, which is again looking at the carbon monoxide here, and the emission was 0.6 kilogram from that combustion. And let's say we have measured it and the quality is high, so update. And then the other emission was sulfur dioxide. sulfur dioxide from combustion. So I'm entering those values which we have initially collected in inventory. And the other emission was methane. And methane emissions is 0.4. So again, we enter date. And then we go to the nitrogen oxide, which is, so it's not nitrous oxide, but it's the oxides of nitrogen, so NO2, and the quantity is 0.02. Okay. And then there was as we're saying, there is a biogenic CO2, which we don't need to enter because anyway it would not be accounted. But if we want to, any for completion purpose, we want to account it, mention it here, we can include it. So we look at the carbon dioxide biogenic. I think it shows here under GHG emission, carbon dioxide biogenic. We can enter it here. So it was this value for biogenic emission. As you see, the impact is 0, so it would not be taken into consideration in any way. So update. And then there was another output from here is so these all were the emissions which we have now defined from the combustion are shown here. And then the output is electricity. But as we mentioned there, from the CHP plant, there will be a lubricant oil, because as we see here, we have as an input, and this probably once we used it, it's going to be disposed of. So we can put as a defined waste and find the waste disposal for, I think it's called under mineral oil, maybe you can see mineral oil, I think it is. So disposal of mineral oil, it is in, yeah, disposal of used mineral oil. Again, it's differently named as, instead of lubricant oil, it is named in the system here. So we can select this one, and the quantity was 0.5 kilogram, and the, say hi, and cost of disposal, okay, we say there is some cost of disposal, and I just put at €0.5. And so this is going, okay, this disposal is going to hazardous waste incineration. As we're saying, this waste will require incineration, so we have added that value. So this is just as an example, if there is any waste stream coming, we can add those values, and this will also take into account those emissions. So now we have defined the second stage, which is CHP plant, and it means at the top level, it will show us the cost and then impact occurring from the carbon footprint from that stage. And so now next for us was the defining the third or final stage, which was in this case study was the digested application. So again, here, when we apply that, there are, there is a emission in terms of ammonia, methane, nitrogen oxide, which we can add here. So again, same way as we were doing in the previous stages. So if I click on ammonia emissions here, so ammonia was 11.4 kilogram, and update. So this will add, and then if we click on the other emission sources, which was methane. So if I go down, methane, we have 0.02 kilogram from that application. Again, it could, let's say we don't have a very reliable quality, we say low. And then we have nitrogen oxide. So nitrogen oxide, which is this one, NO2. Nitrogen oxide is 1.1 kilogram, and low. And the another emission was also nitrous oxide because of the manure. So you can have a nitrous oxide, which is here, which is a very potent greenhouse gas, and it's relatively small because from this digestate. We add that, and in addition, from the application there will be a leachate, which we mentioned nitrate form, and we also want to take into account. So emission to the fresh water, and that leachate is nitrate leachate. So let's find it. Any nitrogen leak to water, or is it, yeah, in terms of nitrogen. So this is here, it is mentioned as 7.5 kilogram. So we add that up there. This is also will like reduce the burden of fertilizer, but which we can do, you know, allocation or crediting. But I think for simplicity, we are not doing it, but that can be also added or credited. So now we have found the what are the application related emission. Oh yeah, I missed one thing. So use of energy in form of machinery. So there is we said diesel usage. So diesel we can find under here. There are option diesel is burned in the building machine on chopper. Also we can look under the CCaLC database. We have option of diesel burn in I think diesel simple diesel or diesel burn in a farm machinery as well. So this is probably more relevant. So I can select this one, and there was 200 megajoule of diesel equivalent energy needed, and operating it. And cost of diesel, I just let me add say €5 required. Okay. All right. So once we add that, so now we have entered all of our data in this study, and once we have completed this, now we can look at the overall results, etc. So I'll go back to the top level. So now you can see it shows that the total carbon footprint of this for this particular case study is 302 megawatt or 302 kilogram per megawatt based on the information we entered. And the cost, again, the cost we have been entering, we are making it these numbers. So if these numbers are correct, then the cost of it will be €1,000, which is a bit higher. Yeah, I think maybe I have added for, yeah, these, I think the cost probably reason is for diesel, I put cost very high. So it was, for 200 megajoule can't cost 1,000. So I think I need to change it. That's why the all results look a bit odd. So cost of it's a per megajoule cost. So it will be maybe 0.2, 1 maybe. Let's say, because I was just putting as a 1 liter, but it's not one. It will be 0.01, let's say. Yeah, that makes sense. So 5 liters maybe cost €4-5. So just adding a bit of cost. Yeah. So now, yeah, these values look more reasonable in terms of a cost. So yeah, if we by mistake enter incorrect data, we can always go and check and see why this is the case. And now if we want to look as in terms of hot spots, where that is occurring, so it's best way is we can look at each graph at individual stage, but also we can look at the summary stage. So we look at view CF summary, and if I click on that, and then it will show in a pie chart. So for example, 60%, 60 or 70% of emissions are coming from production, 20% here in the case are from materials, 9% from transport. And then we can look a little bit more detail from where the production is causing. So it could be, it's a lot of from AD plant, then some from digester and CHP plant. Also materials, because some materials like agriculture, they have some contribution. And if we want to look a little bit further down here, so there are direct from what type of emissions. So the lot of emissions are occurring because of direct greenhouse gas emissions occurring during the AD plant or combustion, but also a little bit from energy and materials, which is like feedstocks. So that will give us a quick summary and here. And then if we want to look at the more graphs, we can again click on those buttons here or under summary data. So if I click carbon footprint graph, this will be, and I can, so raw materials, for example, contributing 60, I can look at which raw material is contributing. So I can click further. It says most of them emissions are related to wheat straw and followed by slurry. and so on. And if I go back to higher level graph, I can look at the production, and again production, which process, AT plant, and within AT plant, what is causing, I can click it's direct emission. We can, so it's nitrous oxide is contributing around 18 kilogram, but methane is the another major source. Ammonia and hydrogen sulfide, they do not directly, they are not greenhouse gases, so there is no impact shown. But if we look at maybe acidification or other impacts, these will have some relevance. Yes, so the other was the transport. Yeah, so if we can look at it, we didn't have any storage or use, so that's why they are showing no emissions. But under transport, then it shows the emissions are occurring because of the transport of feedstock. Also, if we are digested, so they show the breakup. Yeah, in terms of a data quality, if you want to check, we can always click, and then it shows now medium, because there were few data we have a low quality. Also the background data, which a lot of we use from the equipment, which we know are good quality. So that factor is taken into account as well. As a result, the overall data quality of a study in this instance is medium, which means some of the data, if we want to make it a high quality, we need to have a more primary data for all those sources. The other, so again, waste management, we have a little bit of waste, so we could look at that here, only one waste, but if there are more streams, they will be shown accordingly, and we can also view in a graph from where this waste stream is coming and what is its total impact. The other features, as I was showing, we can look at the comparisons. So if I click on comparisons and maybe carbon footprint, so I can, first I clear this previous study, and now let me add this current analysis, and then it will show. And if I want to compare with another study, again, probably, I'm not sure we have energy terms, what we have in energy maybe. So there is energy from solar, for example, but I think their function unit, I'm not sure whether it's a kilowatt hour or megawatt, but let me add one of them and just for the sake of addition. So yeah, this was per kilowatt hour, but here we have a megawatt. So if we wanted to compare, we may have to change for function unit. And just an example, once we enter that comparison, we can add another, say I want to add another case study from energy, and say let's, instead of solar, we look at the wind turbine. So again, that is per 1 kilowatt hour. And then we can look at in a graphic form, and it will show us, since because of the main difference, because of the units, our biomass is showing relatively higher. But if we have a same comparable units, let's assume for the same comparable unit, then it can easily show which one process is showing in which is stage higher or lower emissions in terms of comparison. Yeah, another thing which is, once we have completed a study, we can save, and it's generally save as first study. Then it will ask the option, and it will save as a .CCaLC file at wherever your preferred location, and then which you can later again recall that study. In terms of exporting, again, you can export all those graphs which we saw so in case you don't like this type of bar graphs, you want to do in a little bit in a different graph, you can export and click it, and then it will save as an Excel file. Besides that, there was value added, which was the cost analysis. We can see the breakup of the cost added as well, and here we have whatever data we had, it's showing, and we can show in a graph form where the cost is being occurring. So that will show here. I think I have gone through all of those features which we are supposed to do in this case study. So I can take we can take some questions if there are any related to this study.
Thank you very much for this. This was really very informative and actually very detailed explanation of how the software works. And I think it's actually, it could be very useful also, like in our work. It's simple enough, but it has all kinds of functionalities that are easy to access, unlike in maybe other professional LCA software. So I think that the tool looks really good. I have one question regarding use of other data than the data that is built in the software and our own collected primary data. So is there any way how to import, for example, the newest eco-invent data, either process by process or even the whole database if one has a license? And if it is possible, in what format that data should be? Does your tool support EcoSpot format, or should one just, for example, export from the eco-invent database inventory, life cycle impact assessment per each process, and then somehow import it? Is there any easy way?
We have this on import data option. We had previously we had a previous version which was built in Excel. We had this option to, at that time, ILCD format. We could export, but we had some issues in importing this, so we have currently disabled from that. So that was a relatively quicker. So if we can, say for example, eco-invent or any other database, we convert it to ILCD and then just import it, and it will show as a full database. The other option is this as an import data as an Excel CCaLC file is one option, or user defined. Means I'll go 1 minute before going that. There is a under each. So if there is only one or two or relatively fewer data, so these can be added here under under each material, energy, or packaging. When we click modify database and create new item. So this is only means more useful if we are entering fewer data like 1, 2, 3. Then maybe it's relatively easier to enter and add everything. But the other option, if there are a lot of data, then this user-defined database, there's the option, but I'm not sure at the moment this is fully functional. And Excel CCaLC, I would have to look, because in previous version we had, but I think we had there is a user-defined database, but which format it accepts, I may have to look a little bit, and I think I can have to check it. How it can be imported in that way.
Okay, thank you for that. So maybe the manual approach might be more applicable, and if one is interested only in carbon footprint, then that shouldn't be a problem, because it's copy paste in one value. So only in case we would like to look at different impact categories, then some kind of more automatic way would be useful. But
yeah, and previously we did for the user that with our own developer, if we can, like for eco-invent, they needed like for latest version of eco-invent data, and for once they have a license, I think we extracted the data, but again put in the way our data format is designed in that at our end, and then send that tool back to the user. At the moment, I think we are not doing that, but I can check how, means if there is a lot of our lump sum data needed, then maybe this, we could check how could be done.
I might have still one additional question. I think no one is probably asking anything. Is there any way, or is it possible to create an impact category, or are those that are defined in the software the only impact categories that one can use? I'm just thinking, for example, about resources consumption or something like that. If we basically to calculate material flow analysis, because this tool could be used for that. So if that would be possible.
No, at the moment, no. Means as a user, we can't do it. It doesn't allow to make, these are all built-in features. I mean, in theory, at our end, like our programmer can do it. Means we can make a new category, add it, and then add the those characterization factor and whatever we have to create that type of thing. But as a user, no, it can't be. So we decided initially at that time that these are more relevant impacts to look at, and then we just focus on those. And yeah, based on their requirements, we just focus on these only impacts: the carbon footprint, acidification, U-tree, ozone layer, photochemical smog, human toxicity, and later on we added two others: water footprint and energy use, which you can see separately. So yeah, at the moment it's not possible in a to be done.
Okay, thank you. So no one is asking anything. I think everybody is probably tired from the extensive exercise, but thank you very much, Harish. This was really useful, and we have recorded the webinar, so we will distribute the link to everybody who registered, and probably also to other people who are involved in the project, so everybody can go back to it, and if they will be modeling their own systems, then this will serve as a very good reference, because it's something different to read a PDF manual of 70 pages than to listen to somebody who knows the program very well, and then it's easier to work. So unless you have anything to add, I would thank you very much for your presentation, and I wish everybody a nice sunny afternoon. At least here in Helsinki it's sunny and springy, and yeah, I guess we can stop the webinar.
Yeah, thank you very much. I don't have anything to add, and I thank you for all participants for listening and paying attention. I hope they found it useful, and if they have any questions, then yeah, they can always ask us related to this tool.
Excellent. Thank you very much, and have a good day.
Same to you. Thank you. Bye.
The Circwaste project receives support from the LIFE program of the European Commission for the production of its materials. The views reflected within the content are entirely the project's own.